Okay, welcome to today's lesson where we'll be looking at electricity. An interesting topic, electricity. So under electricity, we have several outcomes that we need to look out for. Outcomes. So implying that by the end of this lesson, all of us should be able to define what current is, and we should be able to calculate what current is. So we'll look at current, then after current we'll also look at electromotive force. Then from there we'll look at another component, which is potential difference. Then we'll look at another component, which is resistance. Then last but not the least, we'll look at circuit diagrams. So I would encourage you to look out for videos. So we're going to do separate videos for current, electromotive force, potential difference, resistance, and circuit diagrams. So now we're going to start with current. Okay, so before we talk about current, we need to define what electricity is. What is electricity? So by definition, electricity can be defined as a form of energy that results from the presence or flow of electrical charges. So we need to have electrical charges that are flowing in a particular conductor for electricity to happen. So now, once we have defined what electricity is, we should also be able to define what current is. Current, which is our main issue that we are looking at today. What is current? So current is defined as the rate of flow of electrical charges. So current does not just flow anyhow, so it flows in particular substances which are known as conductors. So examples of conductors are copper. So in a copper wire, we are going to have electrons that will be able to necessitate or facilitate the flow of current. Okay, then from there we need to also be able to look at what are the SI units. SI units for current. What are the SI units for current? So SI units for current is ampere, which is denoted by symbol capital letter A. Then, since we are talking about the flow of electrical charges, therefore we need to also know the SI units for charge. The SI unit for charge. So the SI units for charge is coulomb, which is denoted by capital letter C. Then again, we should be able to know that it's possible to measure the flow of current. So there's an instrument that is used to measure the flow of current. Current can be measured using an instrument. An instrument which is called an ammeter. So an ammeter is an instrument that is used to measure the flow of current. The flow of current is measured by using an instrument known as an ammeter. So now, in most cases, the ammeter is connected in series with other components to measure the current flowing in a particular circuit. Ammeter is connected in series. Okay. So now, having established all these factors, we now need to talk about the formula that can be used to measure or calculate current. So formula for calculating current is current is equal to charge divided by the time taken. So I is current. I represents current or flow of current. Q is charge. Then small letter t is the time taken. Time taken. Okay. So usually time is in seconds. Time is in seconds. Then the units for charge, as we established earlier, is C. Then the units for current is amp. So now we are going to look at examples on how to calculate current. Examples for calculating current. So example number 1, we are looking at a question which reads as follows: what is the current if a charge of 10 coulomb flows in 5 seconds? So we are required to calculate for current if we have a charge of 10 coulombs in 5 seconds. So from what we discussed earlier, we were told that the formula is current, which is equal to charge over the time taken. So now we need to come up with data from the question as to whether what are we given so that we can be able to calculate. So do we have current from the question? Do we have a charge from the question? Do we have the time taken from the question? So now the question wants us to find the current. So the question wants us to find current. But are we given the charge? Yes, the charge we are given that we have 10 coulomb. Then what about the time taken? The time taken, yes, we have we are told that we have 5 seconds. So now that we have our data here, so it's just a matter of replacing from our equation. So we are going to say, since we are looking for current, so what is our charge? Our charge is 10 coulomb. Okay, then what is our time taken? Our time taken is 5 seconds. 5 seconds. So now we need to divide. So if you have your calculator nearby, you can just calculate 10 divided by 5. So you're going to realize that the answer that you have is 2 amps. Not forgetting the units for current, which is amps. So 2 amps is the correct answer there. Okay, so the second example is the question, which reads as follows. How long would it take for 50 coulomb of charge to flow if the current is 2 amps? So as usual, you are supposed to just come up with a formula. You're supposed to come up with a formula which is current is equal to charge over the time taken. So like we did in the first example, we need to come up with the data from the question. So do we have current? Do we have the charge? Do we have the time taken? So from what we have, yes, we are given the current, which is 2 amps. What about the charge? Yes, we are told the charge is 50 coulomb. But what about the time taken? The time taken is what we are looking for. So now, what you need to do here, you can either try to change the subject of the formula, or you can just replace and do the calculation directly. So to make it easy, I think I will just go direct without changing the subject of the formula. Then from there, the calculation will help us get to what we are looking for. So on current, we are replacing with 2 amps. 2 amps. Then what about charge? On the charge, we are told that we have 50 coulomb. Then we have T. Okay, so we are going to cross multiply. So we are going to have 2 amps multiplied by T. Then 1 times 50 is 50 coulomb. Then we divide both sides by 2. So what we are going to have is 2 into 2, 1, 2 into 2, 1. So we'll remain with so 50 divided by 2 is 25. And what are the units for time? Seconds. So our answer is 25 seconds. So now I want you to work out example number 3, and you can try and solve and see if you can get it right. Thank you very much for watching.